Hi, welcome back. Today we're going to look at trigonometric functions of any angle. Now before we had only looked at the unit circle, which has a radius of 1. But we can actually find the trigonometric functions with any angle and any radius. So when we consider sine of theta, well, that's going to be the y value. I'm going to draw the y right here, over the hypotenuse, so the opposite over the hypotenuse, and we can say that that will be the radius r. So sine can be represented, the sine of the angle can be represented as y over r. The cosine can be represented as x over r. And then the rest are all the reciprocal functions. So when we look at cosecant and secant, you can see those reciprocals. And then tangent, again, is going to be the opposite over the adjacent, which is y over x. Now let's look at this example. So here we have a point, -2, 3. Well, you could probably identify really quickly that that's going to be in the second quadrant. And I'm just going to draw a little triangle here. So we know that that x coordinate is -2. The y coordinate is 3. So it's going to go to the left 2 and up 3. Well, to find that radius, that's easy. You just use the Pythagorean theorem. So we know that's going to be the square root of 9 plus 4. So that's going to be square root of 13. All right, so when we consider the sine of theta, remember it's the opposite over the hypotenuse, or y over r, well, that'll be 3 over root 13. So I'm going to rationalize that as 3 root 13 over 13. Cosine will be x over r, so that's -2 over root 13, and when I rationalize it, that's -2 times root 13 over 13. And the tangent of theta, this angle I should draw it right here, is going to be y over x, which is 3 over -2, or I could put -3/2. Now it's really important, and I think you could see this really quickly, the tangent is going to be the slope, so y over x. All right, let's try this next one. So the sine of theta here is 4/5, but they also tell us that the tangent is going to be negative. It's going to be less than 0. So when we consider which quadrant it's going to be, well, remember sine can be positive in the second quadrant and the first quadrant. So it has to be one of these, but the tangent will only be negative in the second quadrant. So this angle must be, or this terminal side should be in the second quadrant. So we know that this is going to be 4, this is 5, and then you can see really quickly that this will be 3, 4, 5. And the cosine, remember, it's going to be negative. So the cosecant is just the reciprocal of sine. So that's easy. That's just 5 over 4. And the cosine, well, that's going to be -3, the x, over the radius. So -3/5. Now, whenever we look at rotations and angles, we want to try to make it easier for ourselves. So we're going to try to find a reference angle. We've talked about this in previous sections, but now we're going to practice this a little bit more. So reference angles are going to be acute angles. So between 0 and 90 degrees, or 0 and pi over 2. So the key part you need to figure out is the reference angle always lines up with the x-axis, with the horizontal axis. So the reference angle is always going to have one side on the horizontal axis. And the terminal side would be, somewhere else. So if we have this angle that's in the second quadrant, to figure out that reference angle, you're going to have to subtract that angle from 180, or subtract it from pi. If an angle or rotation falls in quadrant 3, or the third quadrant, I should say, then you're going to have to find that reference angle by subtracting 180 from the angle, or pi from that angle. So it's just a little bit of the reverse for quadrant 2 and quadrant 3. Now I think the easiest one is when it's in quadrant 4. So whenever it's in quadrant 4, you just subtract it from 360 or 2 pi. And again, if it's an acute angle in quadrant 1, you're already there. You don't have to find the reference angle. That angle will be the reference angle, as long as it's not over 360, right? So if it's a coterminal angle, you just have to find the acute coterminal angle. Okay, so for each of these, we're going to find which quadrant they land in, and then we'll calculate the reference angle. So 110, you guys know really quickly that that's going to fall in quadrant 2, or the second quadrant. So if we wanted to find this reference angle, and you could use theta prime, I often use alpha here. So if we want to find this angle, we're going to have to just subtract 110 from 180. So that's some easy math. That's just going to be 70 degrees. And remember, our reference angle will always be an acute angle. Now, when you have something in radians, it makes it a little bit more tricky. But remember, this is 180 or just pi. And pi is about, right, 3.1415, it keeps going, right? But 3.5 is just a little bit more than 3.14. So this is going to be in the third quadrant. So this right here is 3.5 radians. So if we're going to find this reference angle, well, we're just going to have to subtract pi from the original angle. For the last one, we have an angle that's going to be in the fourth quadrant. It's a negative rotation, and it's going to be negative 50. Well, you can see pretty quickly that this has one, the one side on the horizontal axis, the terminal side. So the reference angle is just going to be the positive value, 50 degrees. It has to be an acute angle. All right, for this next one, we're going to practice finding the trig values. So we want to actually create those triangles, find the reference angle if we need to, and then use those ratios for sine, cosine, tangent. So sine is y over r, cosine is x over r, and tangent is y over x. So right here we have a special kind of problem. It says the terminal side lies on this line. Well, we just need to first isolate y. So that's going to be negative 5 halves x. And if you remember, I said something about the slope being equal to the tangent, right? So let's put this on a graph here. And I'm just going to graph just a line here with a negative slope. The problem says this line, or this, I should say the terminal side, is going to be in quadrant 4. So I really don't need to worry about in quadrant 2. It's going to be down here in quadrant 4. So if the slope is negative 5 over 2, well, that's also telling us the ratio of the sides, and tangent would be negative 5 over 2. So we can see that really quickly. So I'm going to list these over here. So tangent of theta is just negative 5 over 2. Well, if we want to find the sine and the cosine, the only thing we're missing is the radius. So the radius, again, would be the square root of 25 plus 4. So that's just going to be square root of 29. So remember, that is going to be positive. The radius is always positive here. So the sine would just be opposite over the radius, or y over x, or sorry, y over r. And I'm just going to rationalize that. So negative 5 root 29 over 29. And then cosine will be 2 root 29 over 29. All right, for these last two, what we're going to do is draw these triangles. We want to find the rotations that have these ratios of cosine of theta equals root 3 over 2 and negative root 3 over 2. All right, so let's just go back to the basics here. So we know that the cosine is the adjacent over the hypotenuse. And if you could tell right away, that's going to be a 30, 60, 90. But we know that we want to have this in radians. So 30 degrees is pi over 6. So cosine is going to be positive in the first quadrant and in the fourth quadrant. So the first rotation, well, that's easy. We know that's going to be pi over 6. I'm going to write that a little bit more clearly here. The second rotation is going to be in the fourth quadrant. And we want to make sure we have it between 0 and 2 pi, so we can't write negative pi over 6. But we can say, well, that's going to be 2 pi minus 2 pi over 6. So 2 pi minus, let me just write it over here. Well, okay, so right over here, it's a little scrunched over there. So 2 pi minus pi over 6. And remember, to find a common denominator, you would just have to make this 12 over 6. So that's going to be 11 pi over 6. So we have 2 rotations, 2 angles, 2 solutions, where cosine of theta equals root 3 over 2. Now we're looking for when is this cosine, or the cosine of that angle, going to be negative root 3 over 2. So that's going to take us to the second quadrant and the third quadrant. So the same reference angle, pi over 6. So in the second quadrant, well, that's just going to be pi minus pi over 6. And that we could rewrite that as 6 pi over 6, right? So that's going to be 5 pi over 6. So that's going to be in the second quadrant. And in the third quadrant, it's going to be pi plus pi over 6, right? So that'll just be 7 pi over 6. All right, so looking at this lesson, quick review. Make sure we know how to find those values. What are those relationships between x, y, and the radius for the trig functions? Make sure that we can figure out how to calculate the reference angles, knowing which quadrant they are in, or the terminal side lies in, and subtracting or adding that to 180, pi, or 360, and 2 pi. And lastly, looking at these relationships, we can always go back to the unit circle, to special triangles. There are a lot of ways to solve these, and we also know the trigonometric identities. So whichever method works best for you, try that. But just make sure you're really careful with what the question is asking and the restrictions, specifically for any time we have to find these solutions. All right, I hope this lesson was helpful, and I'll see you all in class.